Hi, this is Todd with the Land of Math. Now I teach middle school math. And so in this video I'm going to look at some different hacks that I'd like to share with middle school teachers, or at least middle school math teachers. Language arts teachers, you're sort of on your own. Good luck. I've been teaching math for over 20 years. Got a couple of awards, and as a matter of fact I've been teaching long enough that back in the day we call these tips and not hacks. But regardless, I have 10 different hacks to kind of help out middle school math teachers when things get a little wonky. I think I'm going to quote the legendary mathematician Mike Tyson when he said, "Everybody has a plan until they get punched in the face." Clearly it sounds like Mike Tyson, middle school math teacher. We've all had this situation where we're coming into a class, we feel like we're prepared, we got a killer lesson plan, everything is on point, we're looking good, we're feeling good. And then right away things go off the rails. The kids don't understand what we're talking about, stuff that you thought, previous knowledge that you thought they already had, they have no clue about. And so right away you have to kind of like change gears on the fly. You have to sort of ad lib. In those situations, it's good to have a couple little guides to kind of help you out. So in this video, I want to talk about some different things that I have kind of like in my back pocket or my little toolkit of math or math teaching skills. And maybe I'll share these with you. Maybe a couple of them will help you. Maybe you have a couple of suggestions you could give for me as well. Always looking to learn. So without any further ado, 10 hacks to help middle school math teachers. All right, the following are 10 tips to try to help you out a little bit when your lesson plans blow up and you have to kind of improvise on the fly. So first of all, try to use factors of 24 and 30 anytime you're adding fractions. Now the main reason for this, it gives you a lot of options and you're never stuck with a denominator like in an answer that's going to be greater than either 24 or 30. So that's going to give you a lot of options. So first of all, there's 7 different factors if you don't include the 1 of 24. Just taking any combination of these two factors, for example, like a 12th and a 24th or a 3 and an 8th, guarantees that you're not going to get an answer with a denominator greater than 24. So if you're working with somebody that's struggling with adding fractions, you don't want a really large denominator. It's the same thing with the 30s. The 30s give you 7 options, not including the 1. As long as you add any combination of those factors as your denominator, you'll never get a number greater than 30, and sometimes less. Another one, try to avoid answers with improper fractions when you're first starting out. So I'm assuming if somebody's struggling with fractions, improper fractions would probably be the last thing you want to show them. An improper fraction just gives you the answer in the numerator that's larger than the denominator. And that obviously equals a mixed number. So a lot of times I try to avoid that at all costs. And it's a real simple, easy way of doing that. So we want to try to avoid, like I said, all these answers right here, these improper fractions. Just make both your fractions less than 1/2. Now again, you can go back to the 24s and the 30s, those factors, but as long as you make sure that both of them are less than 1/2, you're going to be good to go. If you're in a situation where I add three fractions, I always try to make one of them as close to 0 as possible, like in this one, the 1/24th. And that will give you an answer that will be less than 1/2. The third tip is when we're subtracting fractions, make sure the first fraction is greater than 1/2 and the second fraction is less than 1/2. And again, you can use the factors of 24 and 30 like we did earlier. So as long as you make sure the first one's greater than 1/2, the second one's less than 1/2, you'll get an answer that will make sense. So the last thing you want to do is try to end up with an answer where it would be technically like a negative answer. The fourth tip is if we're trying to convert fractions to decimals. What we want to try to do is use factors of 100 as our denominators. And we have a nice little amount to pick from here. The main advantage is we're trying to stay away from repeating decimal. And again, if somebody's trying to learn how to do converting fractions to decimal, the last thing you want to do is like have a repeating decimal. So for example, the fraction 1/3 is a repeating 0.333. 1/7, you can see that one, it's also repeating. Now, both those numbers, the 7 and 3, are not factors of 100. So if you use the factors of 100, for example, like 10 or 50 or 25, the nice thing about that is you're going to get a terminating decimal, usually 1 or 2 digits to the right. Now, if you want to go a little extra crazy and try to go 3 digits to the right, use 8 as your factor. And that'll give you some decimals. They're going to be 3 digits. And usually the odd numbers working with the 8 will work like that. All right, our fifth tip is anytime you're working with percentages when you're starting out, always try to use numbers that are factors of 100. This is going to give you a nice, easy, even amount of percentages without like a decimal. So for example, you can see in all these denominators, I'm using 25, 2, 4, 25, maybe like 50 or something. All those are factors of 100. All right, tip 6, if you're kind of trying to create on the fly, if you're dividing decimals, just use like normal basic division problems and then kind of adjust by putting decimals in different spots. So for example, you have 35 divided by 7, 24 divided by 8. So here I have a whole bunch of 24 divided by 8s, and I'm just going to put decimals in different spots. Occasionally I might add a 0. When you do that, you've created a whole bunch of problems. In this case, we just created 4 different problems. They're all going to have some answers, going to have something to do with 3. You could do the same thing with the 35. So you can see I'm just putting a decimal in different spots on both the numbers, occasionally adding a 0 or multiple zeros. It's a quick way to create a whole bunch of problems with very little effort. All right, number 7. If you're working with circle graphs, always try to use numbers that are a factor of 360. And there's a bunch of these. And so this gives you a lot of options to work with. Now, the main reason is because they're going to divide in there evenly. So let's look at a couple examples. Let's say we pick the number 60, which is a factor of 360. And I'm trying to look at the number of kids and their favorite color. So we have red, blue, yellow, and you can see I picked the numbers 30, 20, and 10. And when I would calculate the degrees for each one, they come out nice and even, equal 360. Here's another one. 120 is a factor of 360. If I find the different amounts of kids that went on a field trip, you can see it comes out nice and evenly. Now, here's a number, the 50 kids. This is not a factor of 360. And when I start to find the degrees for each one, you see I'm stuck with a bunch of decimals. Now, you can just estimate it, but it's probably easier just to avoid it if you can, because it'll make it a lot easier to work with. All right, tip number 8 involves triangles. So with the triangles, we're going to use the Pythagorean theorem to help us with some dimensions. Now, if you teach math, you know that in the Pythagorean theorem, if you square the 2 shorter sides, the legs, and the hypotenuse of the long side, they will equal each other. Now, you can use these numbers right here, the 3 and the 4 and the 5, which are like the base numbers that we usually use as examples to help you make other triangles. So by increasing everything at the same rate, in this case I'm going to double everything, it's going to give a triangle that mathematically actually makes sense. On this one right here, you notice I switched the 4 and the 3. I'm going to multiply everything by 5. You can see my base is 15, height is 20. On the last one, I'm going back to the original triangle, and I'm multiplying by 20. So as long as everything increases the same amount, it's going to mathematically make sense. Because there's always that one kid that's going to call us out if we use something that's not right. You can also do the same with dividing. Like you could divide all the sides by 2 if you wanted to do that. And this actually is kind of nice because it gives us some fractions to work with if you're at that point. So for example, 3 divided by 2 is 3 seconds or a half. We end up with 2 as our base, and 5 over 2 or 2.5 would be our hypotenuse. If we decide to divide by 5, we have 4/5, 3/5 as the base, and then our hypotenuse is just 1. If you're ever in a situation where you have to make up a triangle off the cuff, it's kind of hard to do, and it's easy to make some little mathematical mistakes. For example, using these dimensions, my 7s probably should have really been more like 7.07. And on the one on the right here, if I had a base of 7 and my other sides are 20, the height, I'm putting down 15, but really it should have been more like 15.8 and so on. So you can use this Pythagorean theorem to help you out to make triangles that are mathematically correct. So if I decide to double everything, I'm going to make the height of this triangle 8. That's going to make the 2 sides of the triangle 10 because I'm going to double the 5s. Now, the base right here would have been 6 because I would double the 3. But this is not a right triangle. And so what I would do is I would double the 6 to make it 12, so the base would be 12. The same thing on the other triangle. If I increase everything by 5, the height would now turn into 15. The sides would be 25. Now the part that would be the right triangle on the right side here would be 20, but so the actual whole base would be 40. All right, tip number 9 involves unit rates. So you have a rate, amount, and kind of like a total that you're going to deal with. And you can create a lot of questions. So for example, in your head, kind of pick out like a rate. So for me, I'm going to use $20. Pick an amount. In this case, I'm going to pick amount of time, so 8 hours. And now just kind of multiply those. I like to get numbers that are easy to multiply in my head. 20 times 8 is 160. Now, if you need to kind of like jot this down, that's great. But if you can do it mentally in your head, it makes it a lot easier and quicker. So you can pick any kind of question, just pick 2 of the above 3 things. So if you want to find the unit rate, you just need to know what's the total you made, which was 160, and what was the amount of time, in this case 8 hours. Let's say instead you want to find out what was the amount, okay? So in this case, hours. So you know how much you made, and you know how much you're making each hour. So you can figure out, oh, I must have made $8 per hour, or I worked 8 hours. And finally, if you want to find like the total, so what you would do is you would give what is the rate and the amount of time you worked. So you worked 8 hours, and you're making $20 an hour. And they could just multiply those 2 together. So let's say you're given, or you use the following information. $25 was like your rate. Maybe you had 20 pounds, and you know if you multiply those, you get 500. So you could find out the unit rate, for example. So you could take the $500 and the 20 pounds. If you wanted to find the amount, the numbers you would need would be the $500, again the total, and the $25 per pound. And if you want to find the total, you say, well, $25 and the 20 pounds. All right, our 10th tip deals with equations. Now, if you're trying to come up with an equation on the fly, one of the main things you can do is just solve the problem and then replace one of the numbers with a variable. So for example, this real simple problem here, 2 times 5 plus 3 is 13. I'm just going to take the 5, replace it with a y, and I have an equation. So same with this problem. 20 times 6 minus 4 is 116. I'm going to replace the 6 with a variable, in this case an x, minus 4 equals 116. This next one, I have 2, and I'm going to use parentheses. So it's going to be 2 times 5 plus 7, or 5 plus 2, because I know it equals 7. So I'm just going to replace the 5 with an x, and I have my equation. You can do this with division as well. So 10 divided by 2, I know that's 5, plus 3 is 8. I'm going to replace, and I circled the wrong one here, but we're going to replace the 10. So I'll just make it x divided by 2 plus 3 equals 8. And one last one here. You have 5 times, in the parenthesis is 9 plus 2, which we know is 11, minus 3 is 52. And again, just replace the 9 with a variable, in this case a y, and you have yourself an equation. The nice thing about one-step equations that have division is you can't mess it up. Just pick a number on the bottom, pick an answer, and all you have to do is just take the number on the bottom times whatever your answer is, and you'll get the top number. So these are like a quick, easy one to do. The two-step equations, a little bit more work, but it's still not bad. If you're going to have a division problem with adding, just make sure that whatever you're adding, in this case the 3, is going to be less than your answer. So you want to make sure the 3 is going to be less than the 4. Unless you want to deal with like a negative number, but most of the time you probably want to avoid that if you're just starting out and people have questions. Now, as we get to the next one here, you can see we have x over 4 plus 1 equals 7. So again, we're keeping the 1 less than the 7, which guarantees we're not going to have a problem. On this next one, you can see I have plus 10, but it's going to equal 13. So again, I'm making sure whatever I'm adding is less than the answer. Our last situation is a two-step equation with subtraction. And much like the one step, we can't really mess this one up. We're trying to avoid negatives if we can. And as long as you don't have the equation equal a negative answer, you'll be fine. If your equation happens to equal a negative, then you might have where your variable could equal a negative. But as long as you avoid that, you should have no problems. Well, thanks for watching. Please subscribe and give it a thumbs up. We appreciate it. And check us out on Instagram at Lambda Math, or check out our site, lambdamath.com.